So the next property is ionization potential. So the second property we are going to discuss. Now what actually is ionization potential? The amount of energy required to remove electrons from the valence shell of an isolated gaseous atom. Okay, the amount of energy required to remove electrons from the valence shell of an isolated gaseous atom is called ionization potential. Okay. Now what actually is the meaning of ionization potential? It's the amount of energy required to remove electrons. Now how to remove electrons? We cannot remove electrons and any what you want. To remove electrons from an atom means there should be a neighboring atom which will accept electron. For example, there is a bond between sodium and chlorine. So sodium loses one electron and chlorine takes one electron. Yes or no? So when there is a bond between sodium and chlorine, the electron from sodium is removed out and given to chlorine. So how much energy is required to remove that electron present in a sodium so that electron is accepted by chlorine? So that is called as ionization potential. So amount of energy required to remove electron from an atom. So remove electron from an atom means we have to remove electron from metals. Yes or no? So sodium will give one electron, magnesium will give two electrons, so on. Correct or no? So magnesium requires more energy to remove electron. To remove electron from magnesium require more energy, or to remove electron from sodium require more energy. So that we are going to discuss in this ionization potential. Okay. So the A part is along period. So what happens along period? Along period, number of orbits remain same, that is number of shells remain same, but number of electrons goes on increasing, and due to which nuclear charge increases. In the previous explanation, atomic size also here also it is same. Number of electrons increases and nuclear charge increases, and due to which nuclear attraction increases, and therefore when nuclear attraction is increasing, yes or no, when the nuclear attraction increases, the electron from the last shell cannot be given out very easily. Correct? If electron cannot be given out very easily, we require more energy to remove electron from the orbit. Correct or no? If more energy is required, then more ionization potential is required. Correct or no? So along period, see what happens along period. The number of electronic shells remain same, but the number of electrons increases one by one. Therefore the nuclear charge increases. Correct or no? If nuclear charge increases, then nuclear attraction increases. So if nuclear attraction increases, the energy required to remove electron. If nuclear attraction increases, the electron cannot be easily removed out. So the energy required to remove electron is more If the energy required is more, then ionization potential is more, because ionization potential itself is the amount of energy required. Correct or no? Therefore, the ionization potential ionization potential increases. Okay, so ionization potential along the period will increase. So it is shown in diagram. The ionization potential goes on increasing. Correct. See, so the first element, you can say sodium ionization potential is less, magnesium is little more, and so on. So ionization potential increases as we go along the period. Understood? This is along the period.